So finally, conclusion. And if you have in between, you have any kind of questions, means you may ask me later in question and answer session. So what is big data? Big data refers to extremely large and complex data sets that are beyond processing capabilities. Traditional data management tools and methods and certain techniques are used to handle those kind of data. In internet day-to-day basis, lot of internet users are increased, and lot of internet data is getting generated day by day basis. For handling those data, we use five techniques, that is volume, velocity, variety, veracity, and value. I'm audible right now, right?
Yes,
Yes,
ma'am,
ma'am,
you're
you're
audible.
audible.
Voice is clear.
Hello. Yes. So first one is volume. What is volume means? Generating a data comes under volume. For example, in your SRM student portal itself, all kind of your notes will be available in your student portal. One of your staff is putting those notes in our portal, right? There your staff is creating the volume of data. For one more example is like while you're booking a movie ticket, you give the you by using credit or debit card. There we put credit card and debit card information. There you creating a volume, generating some kind of data. That and all comes under volume. What is velocity? Velocity means how speedily the data is getting generated, how speedily the data is getting moved. It comes under velocity. The best example of velocity is our PUBG game. So while we playing our PUBG game, the user shoot us means it immediately get reflected in our system. Then only we take our next move. Since velocity takes its parts, what is variety means? We have three kind of varietized data, that is structured data, semi-structured, and unstructured data. Structured data is nothing but our student database. It has a predefined manner like rows and columns that are comes in the structured data. Unstructured data, lot of data is generated in day by day basis. 80% of data is comes under unstructured only, like videos, images, voice notes, everything comes under unstructured data. Semi-structured is both the combination of unstructured and semi-structured unstructured and structured data. That is our JSON document. Veracity. Veracity is nothing but data that consists of errors. So checking the trustworthiness of data, the data is trustable or not, we use veracity concept to checking those data. Value. Value means we having some raw data. The data doesn't have any kind of value. For example, if we using YouTube, YouTube collects our likes and dislikes. Using those likes and dislikes, they suggest us some kind of contents. When we use those content, YouTube get benefit out of it. There our likes and dislike data is getting value. Since the value concept is worked over there. This what about the data? Certain tools are used to handle those 5E concepts. One is Hadoop. Today we're going to discuss about. Another is Apache Spark, NoSQL database, data warehousing solutions, machine learning and data analysis. These are all the techniques and tools which used in big data. We use HBase, Spark, Talented, Spark, Hive, Kafka, Hadoop, and Pick. In Hadoop ecosystem, I detail explain you about each and every tool and why we using those tools. Hadoop history. In initial stage for processing the data, Google file system and MapReduce concept is used. Later on, the Docker team is reverse engine those concepts, and Hadoop is introduced in 2006, and its reach is top in 2008. As of now, we're using Hadoop 3 series. Hadoop first series is introduced in 2011. And in 2012, Yarn version is introduced. That is, Yarn is nothing but yet another resource network. It taking care of resource management. In HDFS concept and Hadoop ecosystem, I explained you about yarn concept. So as of now, as of now, we're using Hadoop 3 series. So Hadoop is not a database; it is open source software framework, specially built to handle the structured and semi-structured data as we seen in big data. So as said, it is created by docketing team. It is derived from same Google MapReduce and Google File System only. It's completely programmed under Java concept. So three major models are there in Hadoop. One is HDFS, another one is Yarn, and another one is MapReduce. Basically, we use HDFS for storing our data in a distributed manner. We stored our data in a distributed manner. After that, processing those data, we use MapReduce. MapReduce, they're processing those data which we stored in a distributed manner. It's going to process those data in a parallel manner. Since we use MapReduce, previously MapReduce itself taken care of for resource management. Later on, the MapReduce work efficiency is get reduced because of the large set of data, since the resource management was taken care by Yarn. In as said in Hadoop 2 series, Yarn version is introduced. So going back to features of Hadoop. Features of Hadoop are distributed storage and processing, scalability, fault tolerance, cost effectiveness, data locality, real-time batch processing, security, and flexibility. This kind of stuff all comes under features of Hadoop. First, what does distributed storage and processing means? First of all, it stores the data in a distributed manner. After that, it processing the data in a parallel way. For distributed storage, we use HDFS, and for parallel processing, we use MapReduce. Scalability. Scalability means ability of handling the increased amount of data and workload without compromising its performance. Performance compromising is not happened in Hadoop ecosystem. That's why it is very scalable. Fault tolerance. It is the ability of the system to recover from any kind of failures or errors without any kind of data. Data may not get lost in Hadoop, since the Hadoop and HDFS architecture is designed as like. So data locality means if any of the node is getting failed, means it suggests the nearest node, since the minimize its data movement and improve its overall performance. In this kind of things, I detailedly explain you about in HDFS architecture. Then you all get the clear overview of it. So real-time processing means analyzing the data immediately when they transmitted in the database. Security, as in security, we having authentication, authorization, and editing techniques are there in Hadoop, and it is very flexible. Can process any kind of data independent of its structure. As such, we use structured data, semi-structured data, and unstructured data. So here we're going to talk about Hadoop ecosystem. So Hadoop ecosystem refers to a collection of open source software frameworks and tools built around Apache Hadoop, designed to handle big data processing and storage. So here, what are all the things we're going to do in ecosystem is data ingestion, injecting our data, we storing our data. After storing our data, we processing those data. After that, analysis what will happen, and finally we visualizing our data. So for this process, we using Hadoop ecosystem. Majorly three things are mainly important in this Hadoop ecosystem. One is HDFS, another one is MapReduce, and another one is Yarn. As already told you, HDFS is a Hadoop distributed file system. It stores our data in a distributed manner. For example, I having a 5 MB of data means I'm not going to save my 5 MB of data in a single place. I split the data and save in a multiple places. For example, in our local system itself, we have a separate kind of splitations, like we having a image folder, photos folder, we having the download options, we having desktop options. Like that, I may store my data in a different way. And map reduce means if my data is stored in a distributed manner, after that I process those distributed data in a parallel manner since I used map reduce. After that, yarn over here is for resource management. When and where, what kind of resources are working properly, which of my node is getting failure, this kind of stuffs are handled and taken care of yarn. So for a simple example, consider MapReduce as our CPU, Yarn as our OS, and HDFS as our local file system. In our local file system, we use NTFS and NFS. Here we use HDFS for a large database. That is a small storage. For the small database, we use the NTFS and the NFS. For a huge database, that the same concept was used over here in HDFS. And the HDFS is completely work fine in our local system as well. So, so now the system is ready. How we injecting the data in our system? In our local system, we injecting our data from pen drives, hard disk, and directly we download our data from online. Here we use Scoop and Flume to inject our data. Yeah, if my data is SQL data, it is a completely structured one. I go with Scoop. If it is semi-structured or unstructured data, I use Flume to injecting my data. So as already told you, it is completely programmed under Java for mapper class and reducer class using HDFS concept for this functionality. I have to write 200 to 300 lines of code in Java to Java to make the function happen. And if I know SQL, I want to make the function happen by SQL query means I use Hive to make the function happen. So Pig is also a same concept. Scripting can be used by using Pig. Mahout is nothing but a machine learning platform. All kind of machine learning algorithms will be stored in Mahout using this for machine learning, and Drill is used for interactive analysis. RO is used for JSON types of files, and Crypt is used for cross language services. HBase is nothing but a NoSQL database. Like in RDMS and DBMS, we stored our data in a row and column manner. Irrespective of this data structure, it stores the data in a columnar manner, that is HBase. So OSIC workflow is used to do scheduling the jobs. When which kind of things going to happen, it is scheduled by OSIC. So Zookeeper is also a resource manager. Now you may get some kind of confusion. Yawn is a resource manager. Why are we using Zookeeper? Yawn is a resource manager. Yawn is used for a single ecosystem. If we have a multiple amount of data and multiple ecosystems, we use Zookeeper as a resource manager. Apache Ambari is a used to do monitoring if the ecosystem is efficiently working or not. The monitoring purpose is taken care of Apache Ambari. So moving forward to Hadoop architecture. Hadoop works on a MapReduce programming algorithm. It was introduced by Google. Today, lots of companies and organizations are using Hadoop concept, like Facebook, Yahoo, Netflix, eBay. We already seen about HDFS, MapReduce, and Yarn. Hadoop Common is nothing but Java library, JavaScript, and utilities are stored in Hadoop Common. So in HDFS, that is Hadoop Distributed File System, it is designed to store and manage large-scale data across distributed cluster of commodity hardware. So basically, HDFS consists of two nodes. One is name node and another is data node. Consider name nodes as a master node and data nodes as its employee. Consider name node as your HOD and data nodes as your staffs. In a master node having all kind of rights when which kind of jobs to be performed by the name node is as a which kind of tasks to be performed by the name node is completely handled by the name node. So data node is asset, data node is the employee. For example, I having 580 MB of data. I'm not going to store my 580 MB of data in a node 1. Instead of storing my 580 MB of data in data node 1, I splitting my data into say 128 MB, 128 MB, 4 128 MBs and 18 MB data. Since if I stored my 580 MB of data in a single data node means when the data node 1 is get failed means I may not able to get my data back since I stored this in a different data nodes. This is called as it stored data in a distributed manner. It distributes the data in every node, splitting the data and distribute the data. So now I distribute my data in 5 nodes, that is 180 MB of data. After storing the data, how are I able to understand where which kind of data is stored since we use metadata concept. So going forward to metadata, as said, it stores a huge and large amount of data. It the same hierarchy which Linux and Windows and Linux is called the same hierarchy only. HDFS is also followed. As already told you, NTFS and NFS is designed for a small amount of data, and HDFS is for large amount of data. It's worked perfectly fine in our local system itself. It does not require any kind of additional hardware or any kind of system is not required. It is perfectly work fine in our local systems. So metadata. Metadata is nothing but nothing but a data having all kind of information about our each and every files. The already we seen data node. Data node consists of two files. One is FS image and another one is edit log. FS image consists of file related information. That is, what is the size of file, what is the type of file, in which directory and path the file is stored. That kind of information comes under FS image. Edit log means if the user edit any kind of things in the files or delete the file, change its directory, all those kind of information is stored in the edit log. Whenever we approach the data node to retrieve any kind of data means the data name node check the data, check the metadata and give us the IP address. So the main important concept over HDFS is replication. Um, in this image, we having 5 blocks. Consider each and every block having 128 MB of data. Why we storing splitting our data in 128 MB means in our local system we split our data by 4 KB, 8 KB. It is a huge database, so the minimum splitation will be 128 MB. So each and every block having 128 MB of data. So each and every 128 MB of data will be stored 3 times in different nodes. For example, block 1 is stored in 3 different data nodes as like another blocks are. So whenever the data node 1 is get failed, I may able to get my block 1 data from any other nearest node. For my user, if my data node 3 is nearest to him, I get the data for him from my data node 3, else I get the data for him from data node 4. So next concept over here is rack awareness. Rack awareness is also same like replication concept. For replication, we have just 4 data nodes. Consider for Facebook, for Amazon, we having lots and lots of data nodes. How we handle lots and lots of data nodes means using rack awareness concept. So in this image, if you see, rack 1 contains block A data, and block A data is not repeated in rack 1. But uh, I can send a copy of block A data in any other racks, but not in a rack A. Since whenever the rack A is get failed, completely I lost all kind of data from my block A. Since I stored my block A data in another racks. In this image, you all may clearly able to understand. In rack A, block A is repeated only one time, but in rack B, it is repeated 2 times. As like in block B is repeated for a single time. Here, rack C, block C is repeated for a single time, but block B is repeated for 2 times. So rack awareness is nothing but it is a physical collection of various nodes. That is, block A cannot be stored in the same node, but it stores in another nodes. User want to access any kind of nearest data, HDFS give its nearest rack's IP address to avoid long travel. Stores data locally rather remotely. It is, first of all, the data is stored locally. If locally not able to get the data, if any kind of failure has happened, then only we move to remote data. So secondary name node. Secondary name node is nothing but a PA of our master node. That is our name node. We already seen about in metadata consists of two things, that is FS image and edit log. The FS image and edit log is taken care by secondary name node. Since the name node, master name node is always busy in handling its jobs, handling the data nodes, since secondary name node helps the master name node. So whenever the user change any kind of things in FS image or edit log, the secondary name node only update the things in metadata. So hardbit message over here is each and every data node sends one message to our master name node in every 3 seconds. Since the master name node understand my data node is working properly, working fine. For example, your staff daily basis giving the attendance, right? Taking the attendance, since they understand you're present to the college, like that. Each and every day, like we may have in office, we will be having our check-ins. So from our checking data, they understand that today I attend the office, like that. Hardbit message is sent by the data nodes. If the message is not sent properly, the the master name node understand my data node is getting failed. If the task is allocated already to be, means it is getting allocated by another employee. Like one of your staff is not available today, means the same class will be taken by your any other staff, right? As like name node transfer its job to another data node. So finally, in HDFS, we see about read and write concept. For user want to read any kind of file from this, means he get the permission from the name node. Name node, you are using the metadata, name node understand where the data, where which file is stored, and give the IP address to the user. Using that IP address, user easily able to read the data. For write, it is quite difficult. Since our data is not stored in single place, it is stored in 3 places. As we seen the block images, right? We store our blocks in 3 different nodes. Since whenever the user want to write, he want to write simultaneously. This what about HDFS. Next, we going to map reduce concept. So as of now, we stored our data properly in a distributed manner. After storing the data, we want to process our data, right? For processing also, we need a efficient tool to processing our data that is already stored in a distributed manner. Since we use MapReduce concept, MapReduce performs the processing of large data sets in a distributed and parallel manner. So, what does MapReduce means? First, what MapReduce is doing means it's dividing the large problem into a subproblems and perform the same function on all problems, and finally combine the intermediate output for all the subproblems. So this will be understand properly through this image, like in a, like we having one input over here. First of all, we splitting the inputs into key and value pairs. First, we split it into three things. Consider dir be rear is a data node 1. This is as data node 2 and this is as data node 3. After splitting this, we mapping this. Here, dir is repeated for one time, as like beat for one and river for one, as car for one, river for one, as like we map the splitted content. After that, we shuffle those contents. Here, beer is repeated two times from here and there. As like car is repeated for 3 times, deer is for 2 times, and river is for 2 times. Finally, we're reducing our output. Which are all the things is repeated for how many times? We reducing the output and get the final result. This is what map reduces. That is, it's divide the largest problem into subproblems and perform the same function on each and every problems and combine the intermediate outputs. Here we're using two demos, that is job tracker and task tracker. So as we seen data node and name node in our HDFS concept. So same like here job tracker and task tracker is used. Here job tracker is our master node and task tracker is our employees. So what is the job of job tracker means? As like our name node, here job tracker is also going to assign the task, providing the resources, monitoring the job task tracker, data locality and optimization is also taken care by job tracker, job submission, task recovery, prioritizing the tasks, job completion status are also collected by job tracker, resource management is also provided by job tracker, intercluster communications. These are all taken care of job tracker. So task tracker. So as said, task tracker is our employee. It is responsible for executing the map and reduce task as assigned it by the job tracker. So each task assigned by the job tracker, it handles multiple tasks concurrently. It having the ability of handling the task in a concurrent manner. Task tracker communicates with the job tracker through periodic hotbits to provide the status updates, reports, and available resources. As the secondary node did the same concept, here task tracker itself doing this. It executes the map task by reading input data from HDFS and passing it to mapper function to provide the intermediate key and value pairs, as we seen in the image. Task tracker optimizes the data locality by running map tasks, no nodes where the input data is already present, reducing the network traffic. It performs the task recovery by reporting task failures to the job tracker. Whenever any of the task is reported failed means, it immediately inform it to the job tracker. The job tracker will reassign the task to any other available task tracker. As we seen in the HDFS concept, the same thing is in MapReduce. The same thing is handled by job tracker and task tracker. That's it. So we face some kind of challenges and limitations in Hadoop as well. However, Hadoop's high ecosystem is offer a powerful solution for big data processing and storage. Still they may also face several kind of challenges and limitations. Well, first one is complexity. Second is scalability, data security, performance, data locality, resource management, hardware cost, data loss risk, lack of real-time analysis, tool complexity, community and maintenance, data variety, high availability. These are all the things and challenges which we faced in Hadoop. However, the Hadoop is designed as a scalable and horizontal, but adding more nodes and cluster to it, the large-scale cluster can be challenged and may require careful planning and resource allocation. So, data security, although it is very secure, but still some kind of organizations face uh, some kind of things in sensitive data, dealing with sensitive data, they face some kind of difficulties. Uh, Using HDFS and MapReduce, Hadoop ecosystem is efficiently performed. Still, we face some kind of problems in batch processing of large data sets. Real-time low tendency processing can be still challenging. Never processing the engines like Apache Spark and addressing some other platform issues. So now, why we using Hadoop and big data will be clearly understand by this real world use cases. So, log analysis, recommended systems, social media analysis, fraud detection, healthcare analysis, Internet of Things, data processing, genomic data analysis, supply chain optimization, risk management, and image and video processing. So, what does log analysis means? Analyzing a large volume of data from a web servers and analyze the issues of troubleshooting. This comes under log analysis. Recommended file system. Best example of recommended file system is our e-commerce and media companies. We use Hadoop to build a recommended engine. After that, it offers us a personalized product from our based upon our historical data. As we seen, YouTube suggests us a content in FB also. As per our searches, some kind of contents they are giving to us, right? That is called as recommended systems. So e-commerce and media companies using that. So social media analysis means analyzing our social media data like Twitter data, Facebook data, and post commands. Using this, they understanding they are doing a sentimental analysis and opinion of the customers. So fraud detection is used in financial industry. In financial industry, using a massive data sets to detect the credit card misuse and other subsequent activities will be understand and find it out using fraud detection. So healthcare analysis, analyzing a large amount of patient data for electronic health threats, for medical image researchers, for diagnosis and treatment optimization, healthcare analysis is used. IoT, Internet of Things and data processing, handling a burst volume of data generated by the IO devices allows the businesses to perform the sensor data. So performing the sensor data, Internet of Things and data processing is used. Genomic data analysis means analyzing the DNA sequence of data and identifying the diseases and suggesting the personalized medicines. Supply chain optimization is nothing but a logistics. It is used for transportation and transport industries. Risk management. The best example of risk management is our insurance industries. They accessing the risk profiles and calculating the premium based on our large data sets. insurance claims, etc. are handled in risk management. Image and video processing. Processing the large videos and images by using face recognition, object detection, and video content analysis techniques. This were the things which used in real world. So Hadoop security measure, as like Hadoop also having authentication, authorization, encryption, audit and data protection, administration, and role-based access. So these are all the industries that highly required security measures. One is media, life science, communications, finance, retail industries, advertisements, travels, natural resources, and government. Finally, conclusion. So Hadoop is a game-changing framework for big data processing and management. Since it's store the data in a distributed manner, capabilities make it ideal for handling massive data sets. Hadoop has having a fault tolerance and scalabilities that both ensures the highly availability and efficiency of scaling. It offers cost effectiveness since in HDFS it is not required to use any kind of additional hardwares or any kind of additional system. Perfectly work fine in our local system itself. So by utilizing the commodity hardware and data storage and processing, Hadoop's versatility allows it to handle derived data types, that is structured, semi-structured, and unstructured data. MapReduce programming model enables the parallel data processing for high performance. Yes, we already putting our data in a distributed manner, and we having a tool that is process those distributed data in a parallel manner. So Hadoop supports both real-time and batch processing for a wide range of use cases. The open source ecosystem and the active community focused ongoing development and innovation, organizations can gain valuable insights and make the data-driven decision using Hadoop. Yes, as we already discussed, lot of companies are using Hadoop to handling their big data. Hadoop impact on industries and decision makings will continue to grow as data volume increase.